Okay, welcome to the webinar for Chapter 4, the webinar disclaimer. This WebEx service includes a feature that allows audio and any documents and other materials exchanged or viewed during the session to be recorded. By joining the session, you automatically consent to such recordings. If you do not consent to the recording, please do not join or participate in the session. This WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. Okay, we're going to talk about Chapter 4, and Chapter 4 covers a variety of items: mathematical functions, characters, and strings. I'm going to skip over this preliminary and the objectives, and I will also start off by saying that there are many mathematical functions available to us in the math class. Java provides many methods in the math class for performing common mathematical functions. And we have that availability to us without even using an import statement. It's in the java.lang package, and there's no need to do any import to get access to those math methods. Because we use math so frequently in computer programming, it's just available to us all the time. So let's just take a moment and reflect. We've been working with classes since the very beginning of the semester. Your Lab 1 was a class. Your Lab 2 was a class. Your Lab 3 was a class. Your in-class assignments, your pre-lab assignments have all been classes. And inside those classes that we've been designing and creating and submitting to me, there's really only been one method inside it, the main method. But classes can have a variety of things inside them. A class can have constants, it can have variables, and it can also have methods. We've only been working really with classes that have one single method, the main method. But the math class has constants, it has some variables, and it also has very many methods. And some that are mentioned here are categorized by trigonometric methods, exponent methods, rounding methods, min-max, absolute value, and random methods. Here are the trigonometric methods available in the math class. If you have a need to use sine, cosine, tangent, arc, cosine, arcsine, and arctangent, you can go ahead and invoke the sine method, pass it the angle in radians, and this would be in the math class, and it will return the answer. We're not going to be working too much in this class in trigonometric assignments, so I'm not going to spend much time on that, but you can go ahead and take a look closer at that at your convenience. We do work with exponent methods, and not so much logs, but powers, for instance, and square root. So here's an example where we can use the math.pow method, and we would pass it two parameters. Parameters are inside the parentheses, and each parameter is separated by a comma. So the first parameter in the pow method is 2. This is a positional parameter, which means that this is the base, and this is the power that you're going to raise that base to. So 2 raised to the third power using the math.pow method will return an 8.0. It works in doubles. Here's another one, 3, 2. So we're going to raise 3 to the power of 2, and it will return the results of 3 squared, or 9. It also works with decimals as well. You can pass it 3.5 raised to the 2.5 power, and that will return 22.91765. There is a square root method inside the math class. The way you gain access to that is to precede it with the math class name dot square root and pass it the argument 4, which will return 2.0. Again, it works in doubles. You can pass it 10.5 or a fraction, and it will return 3.24. That's the square root. There also is a cube root. You can take a look at that, but that's not often used. We do use the square root very frequently. There are rounding methods in the math class. We have a need to round very frequently. And I'm going to go right to the examples here. And here in the math class, we have the seal method, we have the floor method, the rint method, and the round method. And here are examples of using each one. I drew a little number line over here to the right in a north-south orientation. So if here is 0, and here's positive 1, 2, and 3, here's negative 1, 2, and 3. Well, if you do math.seal on 2.1, it's going to go over to 2.1 and go to the ceiling and go up to 3 and return 3. Math.seal on 2.0 will return 2.0. And math.seal of negative 2.0 brings you down to here, and it will return you to negative 2. Negative 2.1 will return you to negative 2.0. So if you go down to 2.1, which is a little past negative 2, it will return back the ceiling, which is negative 2. The floor works the exact opposite. So math.floor of 2.1 is going to return you back to 2.0. 2.0 will return 2.0. Negative 2.0 will return negative 2.0, and negative 2.1, the floor of that is going to drop you down to negative 3. Right here. Okay, the rest of these are not that frequently used, but here is where you can go ahead and use rounding methods to get more appropriate answers rather than having these big long strings of decimals. There is the max method, the min method, and the absolute value method. And here are examples using each one. For the max value, you pass it 2 arguments, 2 and 3, it will return 3, the larger of the 2. 2.5 and 3 will return 3.0. Again, it's working in doubles. And math.min of 2.5 and 3.6 returns 2.5, and math.absolute value of minus 2 will return a positive 2 because it's the absolute value. And likewise, negative 2.1 will return a positive 2.1 using the absolute value method. There is a random method inside the math class. Now, we've used the current time in milliseconds, and using the modulus function, we could go ahead and get a random number between 0 and 9. Well, because we have a need to use random numbers quite frequently in programming, there is a method in the math class called the random method. And this generates any fraction, basically going from 0 all the way to 0.9999. Essentially, what the math.random method does is it goes off to the system clock in your computer and returns back the fractional second. Whatever fractional second exists at that particular snapshot in time is what gets returned. So it will randomly generate 0.000001 or 0.9999997 or something like that. So that would be 2 examples on each extreme that it would return, but it would be the fractional second. Now, if you want to generate other random numbers, you can go ahead and use this formula here, where we return math.random. So that's going to return a fraction. Let's say it returns 0.000001. We multiply that 0.00001 times 10, and we're going to get 0.00001. We cast that to an integer, and now we're going to have 0. So you can see that that little example generated the random digit 0, from 0 to 9. Likewise, if the math.random method returned back the fractional second, and it happened to be 0.9, 1, 2, 3, 4, 5, 6, 7, 8, Multiply that times 10, and you're going to get 9.1234567 And we're going to cast it to an integer, and it will just retain the 9. So you can see how this instruction will generate random integers between 0 and 9. This instruction here, 50 plus this times 50, will return a random integer between 50 and 99. So in general, the formula would be as such: a plus net.random, open and close parentheses. It doesn't need an argument passed to it because it knows what it needs to do. It goes to the system clock and gets the fractional second. Plus b will return a random number between a and a plus b exclusive. It excludes a and b. Skipping over the trigonometry or geometry. I want to talk about the character data type. Up until now, we've pretty much just worked with numeric data. And to review, for integers, the smallest area in storage that we can store an integer is in the data type called byte. That would be 1 byte of storage. It can handle a positive 127 all the way down to a negative 128. So rather small integers can be stored in a byte of storage of the data type called byte. The next larger integer area in storage, data type, would be short. And that covers 2 bytes. Whatever you could squeeze into 2 bytes of storage is what you could use for integers of the type short. The next size after short for integers is int. And that's a 4 byte area in storage where you can store much larger integers. And the largest is long, and that can store things like milliseconds since 1970. That's a very, very large integer. It's 8 bytes or 64 bits of storage where integers can be stored. Those are the integers. On the other side, there are decimals that can be stored, or floating point numbers. The floating point different data types, well, a 4 byte floating point data type would be the float, where you can store a decimal in 4 bytes of storage. If you need more precision, you could go ahead and store a decimal in 8 bytes of storage, and that is the double data type. So we've talked about numeric data types, and we've covered just about every one that we can use. Now we're going to go ahead and talk a little bit about character data. The char data type, this is a primitive data type, very similar to int and double and short and byte and long. Those are all considered to be primitive data types. Well, char is another data type. And this char area in storage is 2 bytes, and it can store 1 character. In this case, we are storing the character A in the variable called letter, and it's of the type char. This really should have 2 slashes indicating that this is a comment, but this is an ASCII character. You can also store numeric characters, such as the number 4 in character representation, an ASCII character representation. Keep in mind that whenever you're storing char variables, you need to go ahead and identify them with single quotes. Single quote A, close single quote. And this is the numeric character 4 stored into a variable called numchar. It too is also of the data type called char. Now we're going to talk about Unicode characters. Not that long ago, well, I should say quite a few years ago, when I first started programming, all we really needed was 1 byte to store all the characters on the keyboard. 1 byte can store a total of 256 different values, and there are a lot less than 256 characters on our keyboard. But because programming and computers have gone ubiquitous, and they are all around the world, and they encompass and embrace many languages beyond just English and the English keyboard. We've now had to expand the area in storage from 1 byte to 2 bytes to store character data. And that will also include double byte character sets, kanji code, Greek letters, smiley faces, wingdings, what have you. So there are quite a few different characters that can be stored nowadays, and we now need 2 bytes to store all those characters in. So a way in which you can represent character data is using the Unicode approach. And in this case, we are storing this Unicode in hexadecimal. So there are 2 bytes. The first 2 zeros represent the leftmost byte. The first 0 is the left half byte, and the right 0 is the right half of the left byte. And then the 41 is what has value in there, and that's in the rightmost byte. The left half of the rightmost byte and the right half of the rightmost byte. And this is in hexadecimal. So this 41 is actually a value of 65. 4 times 16 is 64. So we have 4 groups of 16 and 1 group of 1s. So that's a total value in decimal of 65, which happens to be the uppercase A. So this char letter, using the Unicode representation, is the same as using this ASCII representation. This Unicode 34 would be 3 groups of 16 and 4 groups of 1. And that's another way in which you can go ahead and declare and assign character data into a char data type. Note the increment and decrement operators can also be used on char variables to get the next or preceding Unicode character. For example, the following statement displays character B. We declared a variable called ch, it's of the type char, and we're initializing it to lowercase a. This lowercase a in ASCII representation is the value 97. So if you wanted to go ahead and represent that in 2 bytes, the left byte would be all zeros, and the right byte would have the value 97 stored in a bit configuration. So this lowercase a is actually a value 97. If I do a system.out.println line and I do a ++ch, which is a pre-increment on ch, it will take the value, which is 97, and add 1 to it, make it 98. And now, when we print this out, that character value 98 will print out the lowercase b, the next letter in the alphabet. Java code uses Unicode, a 16-bit encoding scheme established by the Unicode Consortium to support the interchange processing display of written text in the world's diverse languages. Unicode takes 2 bytes preceded by a \u, expressed in 4 hexadecimal numbers that run from hex zeros all the way to hex fs. So Unicode can represent 65,535 plus 1 characters. That's quite a few characters now available to us that we can store using the Unicode methodology. Okay, so ASCII code and commonly used characters. For instance, a character 0 all the way to character 9. The decimal value is a decimal 48 all the way up to 57. So these are the actual decimal values. If you put it in binary notation, you would put in a binary 48 for the character 0 and a binary 57 for a character 9. A Unicode value, which is pretty much the same thing except it's being represented in hexadecimal, says this is a Unicode 30, which is 3 groups of 16, which is your 48, all the way up to 3 groups of 16 plus 9, so that's 48 plus 9, brings you to 57. So it's the same range. For the uppercase characters, A through Z, those values in decimal are 65 to 90. Uppercase A is 65, and uppercase Z is 90. You can also represent it in hexadecimal using the Unicode value, 41 to 5 able. And if you translate those over into decimals, those are the equivalent values. Lowercase a to lowercase c is a value of 97 all the way up to a value of 122. Or in Unicode or hexadecimal, it's a hex 61 all the way up to a hex 7 able. Notice the difference between lowercase and uppercase is 32. So the 32-bit will be on. The 32-bit will be on for all lowercase characters. If you want to take a lowercase character and convert it to uppercase, you can subtract 32. And the lowercase a will go from 97 down to 65. And likewise, the same with the lowercase z to an uppercase z. There are some other escape sequences. We've already explored a few. We've explored, obviously, the new line, the \n, and the \t in some of our assignments for tabbing over. There are others, \b for backspacing, \f for form feed, \r for carriage return. If you want to go ahead and put a backslash in your string, use 2 backslashes, and you will then put a \n. If you want to put a double quote inside your quote, use \double quote, and you'll get a double quote inside your string. A lot of these escape sequences are derived from the old typewriter, where you would have a carriage return or a large printer that has form feed where it has fanfold paper, and you want to form feed to the next sheet of paper. These aren't used too frequently nowadays. Okay, here's the ASCII character set in decimal. What did we say the uppercase A was? The uppercase A is right here, and that works out to be a value in decimal of 65. Likewise, a lowercase a would be over here, and that is a value of 97. And here are all the rest of the characters, the ASCII character set, and their associated decimal values. If you have a need to work with them in hexadecimal, here is the hexadecimal table. The uppercase A right here is a hexadecimal 41, which is identical because it's 4 groups of 16, which is 64 plus 1, so it's a decimal value of 65 or a hex value of 41. And you can do the same thing with down to the Z. A Z is a 55 able, and lowercase a is a 61 or 97 in decimal value, and a Z, which is a 7 able. So that's your whole table in both decimal and hexadecimal. Now, casting between characters and numeric types. We could go ahead and code an integer I and assign it a character value, a char value, single quote A. And that would be the same as assigning a 97, a value 97, into this int variable called I. This is the same thing as if you declare an int variable called I, and you are casting the single character A to an integer and storing it into the variable I. Here we have a char variable C, and we are initializing it to a value of 97. It's not in quotes, not in single quotes, it's not in double quotes, it's not surrounded by anything. So it's going to take the value 97, store it into the variable called C. It's of the type char, and it will go ahead and represent the lowercase a. And this is the same as casting the 97 to a char variable and then assigning it into the char variable C. Comparing and testing characters. If you have a need to identify whether or not input coming in from the console is character, is it uppercase, is it lowercase, is it numeric data, or is it something else, you can look at these different zones and determine whether or not it is character data. For instance, if CH, which is of the type char, is greater than or equal to uppercase A, and CH is less than or equal to uppercase Z. Well, if it falls between uppercase A and uppercase Z, you can put out system.out.println CH is an uppercase character. If it's not, if it doesn't fall within that range, ask the next question, else if CH is greater than or equal to lowercase a and CH is less than or equal to lowercase c. If that's the case, it's a lowercase character. If it's neither, if it doesn't fall into either one of those ranges, you can say else if CH is greater than character 0 and CH is less than character 9, then we now know it's a numeric character. Okay, so there are some methods in the character class. There it was the math class, which had many methods, such as the POW and the absolute value that we have available to us. Well, there is also a character class, different from the char primitive data type. And the character class has the following methods available to us that we can use to determine whether or not a character is a digit, for instance, is a letter or digit. This is a typo. That should be letter or digit. Is lowercase, is uppercase, and then we can also take a character and flip it to lowercase or flip it to uppercase using these methods on the character CH. All of these is methods will return Booleans. That means you're going to get a true or a false. That was the character type. There is also another type called the string type. Now, we talked about classes, and the character type and the string type are actually classes. And what are in classes? Classes have constants, they have variables, and they have methods. So the character class has constants, methods, and constants, variables, and methods, and we just went through a few of those methods. And likewise, the string class also has constants, variables, and methods. The char type only represents one character. To represent a string of characters, use the data type called string. This is a term loosely used. It's a data type, but it's really a class. And when you have a class, you want to go ahead and create an object of that particular class in order to gain access to those methods. So what we're doing here now is kind of a shortcut way to create an object of the type string. We have a variable called message. It is of the type string, and we are initializing it to welcome to Java. Now what's really happening here is this variable is a reference variable. It's a reference variable because we are using the string class to create this object called message. And the message area storage is a reference variable that contains an address that points to the area in storage where the object resides. The object is the Welcome to Java object. When we create this object of the type string and the reference variable name is message, then we can go ahead and use all of the methods inside the string class on that object, Welcome to Java. String is actually a predefined class in the Java library, just like the system class and scanner class. The string type is not a primitive type. It is known as a reference type. Any Java class can be used as a reference type for a variable. Reference data types will be thoroughly discussed in Chapter 9 called Objects and Classes, but for now you just need to know how to declare a string variable and how to assign a string to the variable and how to concatenate strings and perform simple operations for strings. Simple methods for string objects. Well, once you create that message reference variable of the type string, you can then use these methods in the string class to explore and examine this string object. We can go ahead and type in message.length, open paren, close paren, and it will return the number of characters in the string whose reference variable name is message. We can do message.char and put a particular index, such as 0, and it will return the character at the specified index from this string. If our string name is Welcome to Java back here, and I put in character 0, it will return the uppercase W from Welcome to Java. Concat S1 will take whatever string we're working with and concatenate it with another string whose reference variable name is S1. That concatenation takes two strings and puts them right up next to one another. You can take a string and flip it all to uppercase, like you did with the character methods, and also to lowercase, like you did with the character method as well. There's another trim method, which will return a new string with any white space characters trimmed on both sides. So for instance, if you had message over here, string message equals blank, 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 welcome to Java, blank, blank, close quote, this trim method will go ahead, if you type in message.trim, it will go ahead and remove those preceding blanks and the trailing blanks and just trim it down to where you have non-white space starting and ending the string. As I said, strings are objects in Java. The methods in the preceding table can only be invoked from a specific string instance. An instance is an object created from that string class. For this reason, these methods are called instance methods. A non-instance method is called a static method. A static method can be invoked without using an object. All the methods defined in the math class are static methods. We didn't have to create a math object to do the POW method or the absolute value method. We could just reference the class name, math.pow, 2, open paren, 2, comma, 3, close paren. Those are static methods, the POW, the absolute value. But the instance methods, the ones we just went through for string and character, you need to create objects before you can go ahead and invoke those instance methods. The syntax to invoke an instance method is the reference variable name, such as message, dot, method name, character at, and an argument. We could put a 0 in there, and it will return back the first character in that string in the message reference variable. Getting the string length. We're declaring a reference variable called message. It is of the type string, and we are initializing it to welcome to Java. We print out the length of, now we can do message, and that will replace this message here with welcome to Java is, we're concatenating is, and we're concatenating message.length. And the length will be, I believe it is 15. getting characters from a string. We have a message, welcome to Java, and we have characters indexed starting at 0, going from index 0 all the way up to index 14. So there are a total of 15 characters in this string. The reference variable name is message. I can use these instance methods, character at 0, to return the uppercase W in message. Message.length will return 15, the length of this overall message, and message.char at 14 will return back the lowercase a, the last character in the message. Converting strings. We're taking a shortcut here and just actually hard coding in the string and saying welcome dot to lowercase will return a new string called that has lowercase welcome. Welcome to uppercase will return a new string, and it will flip everything to uppercase. And here's your trim method, where we're passing it this string that has some preceding blanks, some white space, leading and trailing, and it will remove those and just return welcome without the leading and trailing blanks. For string concatenation, you can concatenate. For instance, let's say you have already declared a reference variable of the type string called S1. And you also have another variable of the type string that you've declared and called it S2. You can now go ahead and concatenate S1 with S2 and assign it into S3. Another way of writing that would be to just write simply string S3 equals S1 plus S2. Because we work with strings so frequently, there are many shortcuts in working with strings, and they're just showing you some that the compiler will accept. 3 strings are concatenated. Here's another little shortcut. You can go ahead and identify that string, welcome, concatenated with 2 blank, concatenated with Java, and those 3 strings will now get assigned into this reference variable called message of the type string. Over here, we have a reference variable called S of the type string, and we are concatenated this string chapter concatenated with this value 2, and because we're concatenating a string with a value, it's going to treat this as a string, and it will become chapter 2. Here's another example. We have S1 of the type string. We're going to go ahead and concatenate this string called supplement, and we're concatenating it with the char uppercase B. And this will go ahead and append the uppercase B onto supplement, and we will have supplement B residing in S1. Reading a string from the console. We're getting scanner input, and we're asking the question, enter 3 words separated by spaces. Okay. Remember we said this is a scanner, this is an object now. So this is a reference variable called input. It's of the type scanner. These are not primitive data types like int and double. These are reference types. So we have a reference variable called input of the type scanner. We're going to create a new object using this new keyword, and that object will get populated with whatever comes in from the console, from the system.in. We ask this question, enter 3 words separated by spaces. Now we can go ahead and declare S1 to be of the type string. So this is a reference variable, which means this is a pointer pointing to another area in storage. that is going to contain the object called S1. And it's going to be initialized by using the next method from the scanner class on this instance of the scanner class, this input reference variable. And that's where we get, if I put in John Quincy Adams, this next method will take John Quincy Adams and store it into this string, whose reference variable name is S1. I'm sorry, I have to correct myself on that. This next will take everything up to the first blank. So the first word in my console input, John, will get stored into S1. The next method will go ahead and take the next word from the console and put Quincy into S2. And this next method from the scanner class, operating on this object, this input object, will return Quincy Adams into S3. So that I've gotten 3 words using the next method from the scanner class to assign them into 3 separate string variables. And this will print out S1 is John, S2 is Quincy, and S3 is Adams. Reading a character from the keyboard. We're getting scanner input, so we are going to create a reference variable. The name of it is input, so that means it's going to have a pointer pointing to the area in storage where we're creating the object of the type scanner. And this new keyword will create that object, and we will use system input into this reference variable. Now that I've created that object, I'll ask the question, enter a character, and I will use the next line method from the scanner class on this input object, and it will return the entire line. The next method just returned each word, but the next line method will return the entire line. If I put in John Quincy Adams, this next line method will return the entire John Quincy Adams into and assign it into S. And now I am using, I am declaring a char variable called ch. This is now a primitive data type, so there will be an area in storage of type char, 2 bytes, and what's going to get assigned into this ch variable is what has come from this object S of the type string, and we are using the character at 0, the character at method, and the index is going to be 0, or the first character in my string input. What did I say? John Quincy Adams. So the uppercase J would get assigned into this ch variable. System.out.println, line, the character entered is J. I'm going to skip over comparing the 2 cities. Obtaining substrings. Substring method on a string where you have a beginning index passed to it as a parameter. And you can also use the substring method and pass it 2 parameters. The first parameter is the beginning index, comma. The second parameter is the end index. So here we have a string. We'll say it's message. And now message.substring 0,11 says we are going to return back the substring that begins at element 0, which is index 0. I'm going to start with the W, and it's going to go a long message until it hits 11, which is right here, and it will return back one before this index. Or you can think of it as the length, 0 for a length of 11. So we're going to go from here, 0, all the way to 10. And welcome blank to blank will get stored in some other string if you're assigning it into another string. If you need to reference this Java, you can write the code message.substring open paren 11. It's only getting one parameter passed to it, so therefore we'll use this method, begin index, and it will begin at 11 and continue all the way to the end of the string because we didn't put a delimiter using a second parameter to delimit how much of the substring we want. So it will just return back from 11 all the way to the end of the string. Finding a character or a substring in a string. Here are the methods. We have the index of method. We pass it a character. It returns the index of the first occurrence of CH in a string. If it doesn't find that particular character in the string, it will return a -1. And then here are some others. Index of the character from a certain point returns -1 if there's no match. Index of string, index of S. Here are all the different last index of, and there's quite a few. Now, here's a good time for me to hop over to my test chapter 4, because the best way to understand these methods inside the character class and the string class and using substrings is to put them in practice. Over here in NetBeans, I have a program called Test Chapter 4 right here, and as each one of these concepts comes across in the textbook or in a PowerPoint, I like to go ahead and code it and make sure it works. So I've done that for Chapter 4. So here's, for instance, all from way back when, the first few slides where it talked about the math class and using the 2 radians and the cosine methods. And here are examples that demonstrate these particular skills and these methods inside these classes. And here's your math pow, your math square root. Here I did a cube root on 27, and you'll see down here, cube root of 27 returns a 3. Here is the math random to return random integers from different zones. So I experimented with it, and I created a few simple statements, and I played with it so I understood it better. I suggest you do the same. Working with the char data. Here is where I experimented with this. Here is where I experimented with the \b, the \f, the \r, \\, double quote, and I could look down here and see how it came out. Here is a section on working with lowercase and looking to see if it's a zone. So we have lowercase a, and it will come back out and say a is a lowercase character. Lowercase a is uppercase, false, a is lowercase, true. A is a digit, comes out as false. Here's where I added 1 to CH, and it now becomes a B. Actually, I did a post increment, so CH is still an A, and then I printed it out after the post increment, and it's now a B. Here we have a couple of strings. String S1 equals lowercase welcome to Java, and string S2 has the uppercase W in Welcome to Java. That's the only difference in the two strings, S1 and S2. And here's where I do a system.out.println. S1 length is, and I can now reference this instance of the object of the string object, S1, and invoke the length method on S1, and it will come back and say the length is 15. S1 equals S2, and here's where the code is, and it says it's false because there is a difference, a very slight difference, the lowercase w to the uppercase W. There's a compare to method where I'm comparing S1 to S2. And that comes back and it says the difference is 32. The 32 can be thought of as the 32-bit. S1 starts off with a lowercase w. S2 starts off with an uppercase W. The difference between those two in ASCII values is a 32-bit, 32 value difference. So this compare to method will go ahead and return the difference in the ASCII values. Now for some indexes, we can do S1 starts with welk, and I'm using S1 starts with, and I'm passing it this prefix welk, and it will come back and it's a Boolean, it will return true. Likewise, S1 ends with AVA. It does end with AVA, and it will come back and say true. S1 ends, well, we just did that one. S1 index of come, and I'm going to do S1.index of come, and the index of come is on S1 is 0, 1, 2, 3. Come begins at index 3, and here is the 3 that gets returned. S1.last index of E will return the last occurrence, the index of the last occurrence of E in S1. Here's the first one, that's at 1, 2, 3, 4, 5, 6. That's the last E is at index 6, and that's what gets returned there from this statement. Okay, so this is a good exercise that you should be doing where you can go ahead and exemplify and demonstrate and practice with these notions that come up in the PowerPoint and in the text. Finding a character or a substring in a string. We have k of the type int, and we're going to go ahead and pass it the index. If this is the string called S, we're going to pass it the index of the first blank. We have the string Kim blank Jones, so the first blank is right here. The index is at index 3, and we're going to assign that into k. So k contains the integer 3. We can now go ahead and assign into first name of the type string substring 0, k. So we're using the substring method in the string class to go ahead and take from element 0, that's from k, all the way up to 3, minus 1, and we're going to go ahead and store Kim into first name. Likewise, for last name, we can go ahead and take s.substring k plus 1 and start with the j, and we're only passing it one parameter, so it will go ahead and return back from element 0 all the way to the end of the string, and it will put Jones in last name. Okay, converting between strings and numbers. There are some other classes, the integer class and the double class. These are all wrapper classes, but inside these classes are methods. And we can go ahead and use the parseInt method on some integer string and store it into an int value of the type int, and do the same thing with a double using the double class. There's a parseDouble method in the double wrapper class on a string of type that would be of doubles and store it into a double value. It's rather confusing, so let's just go to an example so you have a better understanding. I have a string. It has integers inside that string, 1, 2, 3. I'm going to go ahead and store those character digits into a variable called int string. It's of the type string. Now I can go ahead and use the parseInt method on int string and store it into int value. It's of the type int. So I've gotten character data coming in. Even though it's integers, it's still character data. And if I need to do any kind of arithmetic operations on that input, even though it's integer character data, I need to convert it over into an int. And the way to do that would be to use the parseInt method in the integer class, and it will now go ahead and store the value 123 into this int variable. I then go ahead and increment int value by 1. So 123 should then become 124, and sure enough, here it is printed down here. Int value is 124 from this statement. Likewise for the double, I have a character string coming in. It has numeric characters, and it looks to be of a double 123.45. This can get converted over to a double. So I'll use the parseDouble method in the double class. This is a wrapper class. And I'll take double string from here and assign it into a double called double value. Then I can go ahead and increment double value by 1. And 123.45 will now print out 124.45. Okay, so let's go to the next. Skipping over that and going to a hex digit to decimal. We do know the valid digits for hexadecimal numbers are 0 through F, 0 through 9, and A through F. It says here, write a program that converts a hexadecimal digit into a decimal value. Here's the program, hex digit to decimal, and we're getting scanner input. We're asking to enter a hex digit, and we're going to use the next line method to capture that particular digit. Let's assume for the moment that I put in the character C. Well, this next line method is going to take the entire entry, whatever I put in. I only put in one character, but this input is going to get stored into hex string of the type string. First thing I'm doing is check to see if the hex string has exactly one character. Well, the way to do that is to ask the question if hex string.length is not equal to 1. If it's not equal to 1, then I have bad input. And I'm going to put that out. System.printout.println line, you must enter exactly one character, and I exit my program with a return code of 1. And my program ends. But in my case, I put in a character C, so I'll skip over this block, and I'll go to the next instruction here, which says display the decimal value for the hex digit. Now, I know the character C is a value of 12. What I can do now is flip the character C and make sure it's uppercase. So upon the hex string object, I'm going to go to character at 0, which is C, and I'm going to flip it to uppercase. Now I have an uppercase C getting stored into the variable ch of the type char. Now I can test, is that uppercase C less than or equal to F? And is the uppercase C greater than or equal to A? That is true. It falls between A and F numerically. So therefore, I go ahead and I execute this block of code between this curly brace and that curly brace, and I will go ahead and take the characters uppercase C, subtract an uppercase A. Now what's C minus A? The value C minus the value A is going to be 2. Then I'll add 10 to that and arrive at 12. The value 12 then gets stored into this int variable called value. And then I print it out. The decimal value for hex digit C concatenated with is concatenated with the value 12. Okay, let's say, for instance, I entered a 7 rather than a C. Well, it wouldn't fall within this range here, so I would skip over this block of code and execute this next sequential instruction and say else if character is digit. Now I'm using the is digit method from the character class on ch, and I put in a 7, it will return back true. So this whole expression here will evaluate to true, and I will execute what's inside these curly braces and print out system.out.println the decimal value for hex digit 7 is 7. And then finally, if neither of these cases is the case, then I will go ahead and execute this final else clause, which says that I put in some invalid input. So here's a way in which you can capture hexadecimal characters. Okay, the printf statement. Up until now, we've used the print line, P-R-I-N-T-L-N. That is a method. We've also used just a straight print, system.out.print method. And the difference between the print line and the print is the print line will obviously go to a new line. The print will just continue to append or concatenate onto whatever was printed last without going to a new line. Well, we have now another print method. It's called the printf method. And you can use this to format output, especially when it comes to such things as currency. In a few of our assignments, we've had currency output where it may have come out to be $12.50 even, and we put out 12.5 rather than 12.50. Well, this printf method will allow us to format that such that it formats perfectly like currency. After all, up until now, the formatting has been for arithmetic. If we arrive at an answer and it's 12.50, we don't put out 12.50, we put out 12.5 in arithmetic. But in currency, we want to carry the pennies, so we would need to now put out 12.50. This printf method will allow us to do that. Let's look at an example here. We have some code here. Let's make it bigger. I've got a variable called count. It's of the type int, and I'm initializing it to 5. I have another variable called amount. It's of the type double, and I'm initializing it to 45.56. I now am using the system.out.printf, so print with formatting, and I'm passing it 3 parameters. We're opening the parentheses. The first parameter is this big long string, followed by a comma, followed by this variable count corresponding to this, and this variable amount corresponding to the above. This amount corresponding to this amount here. If we look inside the first parameter, which is the big long string, the string consists of count is, and now I have a %d, and amount is %f. These percent signs here, the %d corresponds with this next parameter, and this %f corresponds with this parameter. The %d says this is going to be a decimal integer. And sure enough, the count variable, is an integer. It's a decimal integer. This %f says that what's going to get put in here is going to be a floating point number. %f is for a floating point number. And correspondingly, this variable, this last parameter, amount, corresponds to this, which in fact is a floating point number. It's a double. So everything corresponds, and this will display count equals 5 and amount is equal to 45.56 and 4 zeros. It's still not exactly how I want to go ahead and display a dollar amount. I want to get rid of those trailing zeros. Let's look at the example that I put together in my NetBeans. I have the same code here. Count is 5, amount is 45.56, and I do count %d and amount %f, and here are my corresponding variables corresponding to the %d and the %f, and it will print out count is 5 and amount is 45.56 and 4 zeros. I adjusted this now, and I said a new line. Here's another example, and I have %3d, %2s, and %4.2f, and a new line, all inside my first quote. And my next parameter is an integer, 1, 2, 3, 4, and sure enough, that corresponds with the %3d, which is a decimal integer. The next is a string. I put Java, so %2s will say that this is a string, and then the last is a double, 51.6653, and this is a %f. Now I've got some coefficients in here. I've got some values in front of the D, S, and F. What are those? Well, what this 3 says is that we're going to go ahead and reserve at least 3 characters for this display. Now, I'm displaying 4 characters, so that's fine. But if I was only displaying 2 characters, it would lead it with a leading blank. In this case, I am reserving at minimum 2 characters in this string. I happen to be displaying 4 characters, so I have plenty of room to do that. But if I was only displaying 1 character, it would lead it with a preceding blank. Here is where it really comes in very beneficial. And this 4.2, this says I've got a floating point number, and I do 51.6653. And what I'm reserving here are at least 4 positions, 4 characters and 2 decimal places. So this is larger than 4 characters. This is actually 7 characters, including the decimal point, and it will carry 2 decimal places. And down here, you'll see this example displays 1, 2, 3, 4 Java and 51.67. So this actually rounds this 51.6653 to 51.67. So it actually does the rounding as well. Another example, I do the same thing, %D, %3D, %2S, and %42F, and I use a different number here for the double. In this case, I'm using 51.0016653, and this will print out to 2 decimal places because of this, and at least 4 characters. And I'm printing out 7 characters here, so I now have 51.00. It will round on the 1,000th place and return back to 51.00. So this printf method right here is a very valuable tool, but you have to use this as described in this example. I would strongly suggest you go to the textbook and read the section on the printf, the full description, because that gives the full, all the details on how this printf method works. That does bring us to the end of Chapter 4. And as a supplement to Chapter 4, I've also included some hex arithmetic that will be on the midterm, so you're going to need to know how to do hex arithmetic. And I'll just quickly go through that, and then we'll call it a night. Hex arithmetic we can think of place values for base 16 on the left-hand side here. So let's think of our Unicode characters, for instance, where we have 4 hexadecimal characters. They can all be placed right in each one of these boxes. Each one of these boxes represents a power of 16, or for base 16 or hexadecimal. So 16 to the 0, anything raised to the 0 power is 1. 16 to the first is the 16s column. 16 squared is the 256 column, and 16 cubed is the 4096 column. This is for base 16. If you want to think of things in binary, well, that's base 2. So your first column here is your 1s column, 2 to the 0. Anything raised to the 0 power is 1. So here's your 1s column. Then here's your 2 to the first, or 2s column. Your 4s column is next, then your 8, then your 16, 32, all the way out to 32K. To convert, you're going to need to know how to convert from hexadecimal to decimal. And what we have here is a hexadecimal FF, and how to convert that over to a decimal 255. Another example would be to convert 17 in base 10, 17 decimal, over to hexadecimal, which would be a hexadecimal 1-1. One group of 16s and one group of 1s adds up to 17, the value 17 in decimal. You may have a need to also convert from hex to binary and binary to hex. And here is a byte in storage. This byte has 8 bits all on, and that can be represented as a hexadecimal FF. The easiest way to do that is to draw a line down the middle of the byte right here. The left side is going to be the left half byte, and the right side is going to be the right half byte. And the 4 1s on the left can represent an 8, a 4, a 2, and a 1, which is a total of 15. In hexadecimal, that's represented as an F. On the right-hand side, we have 4 1s as well. That's an 8, a 4, a 2, and a 1. That adds up to 15. So that also is going to be represented in hexadecimal as an F. This one here is a little bit different. You can think of it as no 128s, no 64s, no 32s. We have a 16. We have no 4s, no 2s, and one 1. And that's going to be a total of 17, the value of 17. One group of 16s and one group of 1s. Another way to go ahead and represent that is to draw the line down the middle, and the left 4 bits will represent one hexadecimal character, and the right 4 bits will represent another hexadecimal character. For hexadecimal, we have no 8s, we have no 4s, we have no 2s, we have a 1. And over here, we have no 8s, we have no 4s, no 2s, we have a 1. So there's your 1 in 1 in hexadecimal. Okay, binary to decimal. Do the same thing. Start off by saying I have no 128s, I have a 64, I have a 32, no 16s, no 8s, I have a 4, a 2, and a 1. Add that all up and it comes to 103 in decimal. 153 in decimal, well, you can say I'm going to pull out a 128. No, I'm not going to pull out a 64. I don't have enough for 32. I can pull out a 16. I can pull out an 8, and I can pull out a 1. And that will add up to 153. Arithmetic operations. You'll have a need to go ahead and add 2 hexadecimal numbers, and what you should do is put them on top of one another. So we have hex 1 Abel Baker added with a hex 21, and that overall answer will be a hex 1 CC. Subtracting and a hex F2, and subtract from that a 1B, and we'll get a D7. Binary addition, you can do it 2 ways. You can add them together. 1 plus 1 in binary is 0, carry the 1. Have to carry a group of 2s. 1 plus 1 is 2, but you can't write 2. You've got to put a 0 down and carry a group. So now I have 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 0 is 1. I have 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1, and here's 1. So that's a tedious way in which you can go ahead and add in binary. Maybe an easier way, might be to convert this over to decimal and say I've got no 128s, I do have a 64, I got a 32, and I got a 4, 2, and a 1. That all adds up to 103. Over here, I can convert this to decimal. I have no 128s, I've got no 64s, I do have a 32, I have an 8 and a 1. They add up to 41. I can add these 2 together. 103 and 41 is 144, and then convert it back over and pull out a 128, no 64, no 32. I can pull out a 16. A 128 and a 16 adds up to 144. I'd like you to go ahead at your convenience to try doing these examples here. BAB plus 1BD. Next, for hex subtraction, do hex DAD and subtract a 1B from that and see what the result is. Likewise, do this binary addition. These are your answers for those exercises, and I'd like you to go ahead and convert the following. I'll give you the decimal 22, give me the hex equivalent, and also give me the binary equivalent. I'll give you the hex, convert that to decimal using pencil and paper, not computers or calculators, and also give me the binary. Do all of these conversions, and I do give you the answers, so you can double check your work, but I want you to do this independently without a computer or a calculator and see if you can go ahead and do that. Here's another slide where you can go ahead and do hex addition of these 2. Hex addition would be to go 2 plus 2 is 4, and then F plus 2 is f plus 1 is 0, and another one is 1, so it's going to be 1, 1, 4. And here's your answer here, 1, 1, 4. B plus 2 is D. 7 plus A, we can quickly convert the A to 10 and say 7 plus 10 is 17, but I can't write 17. I have to carry a group of 16. So I'll put the 1 down and carry a group of 16. And now I have 1 plus 1, and I get 2, 1D. Over here, I have B plus C. B is 11, C is 12. 11 plus 12 is 23. I can't put 23 down here. I have to go ahead and put 23, take 16 away, and I'm going to have a 7 remainder, and I'm going to carry a group of 16 over here. Now I have F plus 1 is 0, plus another 1 is 1. I carry the 1, and I have A plus 2 is C, plus the carried 1 makes D, and my answer is D17. That's how I would go ahead and do that hex addition. Hex subtraction, A minus 2 would be 8, and 4 minus 2 would be 2. B minus C, I can't do that, so I need to borrow a group of 16s over here. So this B is really an 11. I'm going to borrow a group of 16, so 11 plus 16 is 27. I'm going to subtract C, or 12, from 27, and I will be left with a 15. 15 in hexadecimal is an F. I borrowed one from over here, so this is now F6. And I can't subtract C from 6, so I have to borrow a group, so I'll change that to be E. And 6 plus 16 is 22, minus 12 is 10, which is a hex A. And I've borrowed one from the F, making this E, so this is an EAF. And I'll leave the last one for you to do. This is only going to come to you if you practice. So you need to go ahead and practice these for the midterm. And that's it. Are there any questions regarding tonight's Chapter 4 and Hex Arithmetic webinar? Okay, I see that Leah joined us. Welcome. Are there any questions before we call it a night? Okay, well, thank everyone for attending, and we will see each other again soon. Take care and have a good night.
You too, Professor. Thank you.